Well, hello guys. As you can see, I'm not there. I'm here, but I'm also not here. This is me in the past. Anyway. So today we're going to be talking about percents of change. I feel like yesterday everybody really hammered the proportions and ratios and was doing super solid on that. So today we're going to talk about percents and changes. So there is a handout that you should have gotten. It's a foldable. So at this time, go ahead and take out your math notebook. Go to your table of contents, and you are going to fill all that info in. And your paper should look something like this. So you are going to need to fold, and you are going to need to cut. So that stuff, if Gabby, you can go ahead and get my scissors and my glue, and Leo, pass out my glue, Gabby, pass out my scissors. And while you guys are passing that stuff out, I'm going to show you how to fold this. So you're going to take your sheet, just like this, and you're going to fold up to that black line there. So when you fold up to the black line, it's going to look a little something like this. So a little something like this. Jalen, stop talking. It's going to look like that. And then you fold the other side. You're going to fold this side to the line here. So they're going to come together. And when you're done folding them, you will have a sheet that looks like this, percent of change. So when you flip this side up, it's going to have all your info here. When you flip this side down, it's going to have all of our examples that we're going to go over. So go ahead and pause the video and let everybody get this handled and glued into your page. Make sure that you date and number your page in your math notebook. When you're done, go ahead and unpause the video. I will be here. Alright, so now everybody should have their foldable in their notebook and ready to take notes. So, what you guys are going to see is when you fold open the top part here, you fold open the top part, it's going to look like this. Percent of change equals line. Well, fear not, percent of change does not actually equal line. Percent of change equals words. It actually equals the amount. So the amount, let's try that one again. It's going to equal the amount, AMOU, amount of change, over the original amount. So the amount of change over the original amount. Let's change that color because that orange is I'm not feeling it. So the amount of change divided by the original amount is what that means. Think of it like when we were doing our basic fraction. The amount of change divided by the original amount. So when we have a percent increase describes, so it describes how much a quantity increases compared to the original amount. Compared to the original amount. So an example of this, an example would be a markup or a cost markup. So markup. So an example would be a markup or price increase. Markup or price increase. So, if a percent increase is described as how much a quantity increases compared to the original amount, a percent decrease would describe how much a quantity decreases compared to the original amount. Oh, much? Whoa, that was some not cool writing. How much a, there we go, describes how much a quantity decreases compared to the original amount. Now, I know your handwriting is going to look a lot better than mine. I'm actually writing with a pad, like a pad for my computer. So I know yours is going to look a little better. So please forgive my handwriting. It's not the greatest. So an example would be a sale, hey, or discounts. Sale or discounts is what that would be. So our notes of a percent increase describes how much a quantity increases compared to the original amount. Example, markup, like a price increase, say when we have a hurricane and gas starts going up randomly. That's the example of a percent increase. A percent decrease describes how much a quantity decreases compared to the original amount. For example, we have sales. I love sales. We get all of our stuff on sale. And discounts. So if you have 10% off, that is a percent decrease. All right, so I'll give you guys a second to catch this up. Go ahead and pause the video if anybody needs additional time. Otherwise, I am going to move on to the next part, which is our examples. All right, so percentage 2. So here's our examples. Let me go ahead and zoom in here. So here's our examples. So example 1 is from 25 to 49. Well, I know that according to my notes just up top that I can't see, but you can, to get the percent of change, we simply take the amount of change, and in this case, the amount of change is going to be 49. So I'm going to write 49 over here. So 49, the amount of change over the original amount, 49 over 25. So I take the 49 over 25, which is the amount of change over the original amount, and I just divide that. And when I divide that on my handy dandy calculator, because, you know, that's how we do. So I have 49 divided by 25. That gives me, that equals 1.96. And what I'm thinking about is my 1 is my original price, right? That's my original starting point. 100%. 100% is my original. So if I am looking for the change here, if I'm looking for the change, my change is going to be this part right here, at 96%. So my change is actually just going to be 96%. So 96%, not too bad, not too bad. So that's an example, and if I'm looking at this, so I know that I've got my whole and then my percentage. So this would actually be an example of a percent increase. So this is an example of a percent increase. The percent, the price or the total went up from 25 to 49. It went up, so that's an increase. So if I'm looking at my next one, my example number 2 here. So example number 2, I think I'm going to do 1, 2, 5, and 6, and I'm going to let you guys try the other ones. So if I'm looking at example number 2, Susie, oh Susie, she's buying her planner, trying to get all ready. She bought a planner for $32. The wholesale cost was $25. What was the markup? Well, it tells us right there that there's a markup, right? It tells us right there there's a markup. So we know that we're taking the amount of change, which is $32. The amount of change is $32. And we're putting it over the original price. The wholesale price was $25. So whoever bought this bought it for $25 and then sold it for $32. And that's how we are getting this right here. So 32 divided by 25 will give us 1.28. So again, I'm looking at this as a markup. I know that this is a markup, so it's going up. It's an increase in price. That's my key right there. That 32 is that it's an increase in price. So 100 is the original, so 28. So it increased by 28%. So the increase was 28%. All right, now this is decreases. We got one extra step. So this is all there is to increases. Not too shabby, not too bad, not too bad. It's easy. Decreases. We have simply one extra step. So we're taking the same philosophy. We got our amount of change over the original amount. So the amount of change from 50 to 45. So the change is 245. The original is 50. So when I do this and I divide on my handy dandy calculator, that is going to come out to 0.9. Now what's happening here is we have less than our whole, right? So what we do is we have to subtract our 1. Subtract 1. So if we have 1.00 minus 0.9, that's going to leave us, after we do our subtraction, that is going to leave us with 10. So the change here, the decrease is going to be a 10% decrease. And in all actuality, we could actually do this over here too. If we subtract, on example 2, if we subtract one whole, it's still going to leave us with 28. It's still going to leave us with 28% increase. Same thing with number 1. If we subtract that one whole, that's going to leave us with a 90% increase. So I think that's what we're going to start doing from here on out. I should have started at the front. I apologize. But I think that'll be a surefire way to make sure that we do not make any errors. All right, so this one, Carlos uses a coupon, and he paid $7.35 for a pizza that normally costs $10.50. Good job, Carlos. Find the percent of the discount. So the amount of change is $7.35. So 7.35 over 10.5. And when I divide this in my handy dandy calculator, it is going to come out to 0.75. So 0.75. And all I'm doing here, I'm just kidding. It's not going to come out to 0.75. It is going to come out to 0.70. And when I take and I subtract my one whole from this is going to leave me 0.30. So 0.30. That is going to mean that there is a 30% sale going on at the pizza place. A 30% sale going on at the pizza place. So this is how we're going to find our increases and decreases. So we know that this is a decrease because he's getting a discount. We know that this is an increase because they're selling for more than they actually paid. Over on example 2. All right. So if we go down to now example 3, 4, 7, and 8. Now it gets a little more complicated. The only thing that's getting more complicated in this is not what we're doing. We're doing the same exact thing. It's just the wording. So they're trying to confuse us by adding more words because words are pretty confusing. So if we look at number 3, at example 3 here, it says bottled water costs $1.25 in the vending machine. This price is a markup from wholesale cost of 20 cents. This is a pretty accurate markup for bottled water. So what's the markup as a percent? So we know that it's a markup, so there's going to be an increase. So there's going to be an increase. I'm just kind of making myself a note. So we know that the cost after the sale is, or after the markup, is $1.25. So we're going to go $1.25, which is the amount of change, over the original amount, which is 20 cents. So, calm down. So, $1.25 over 20 cents. So, $1.25 over 20 cents. That's going to be 6, from our handy dandy calculator, that's going to be 6.25. Now, we're going to do the same thing we normally would and subtract our 1 whole. And that's going to leave us with 5.25. So that means that the markup on this bottled water in the vending machine is 525%. That is a normal markup. I know it sounds crazy. I don't know why people would pay that, but we do. People pay crazy amounts of money for bottled water. So let's go ahead and go down to example number 4. It says, when Bobby was exercising, his heart rate went from 79 beats per minute to 98 beats per minute. Approximately, what was the percent of increase? So, approximately, what was the percent of increase? So we know that it went to 98. So it went to 98, and because it went to 98, the amount of change is going to go on top. Then our 79 is what it started at, which is our original amount. So when we put this into our calculator, it will be 1.24. So 1.24, and we subtract our 1 whole. That leaves us with 0.24 left, which totals out in percentage world as 24%. So Bobby was working out 24%. He was working his heart 24% harder than normal. So I hope we're seeing the pattern here. It's not a difficult concept. It's the idea of making sure that we identify the change versus the original number. So we got to know the change versus the original number. That's going to be the only thing that will trick you up. So let's look at example 7. Samantha bought a book on sale for $3.60. It was originally priced at $12. Good job on that sale, Samantha. What was her discount as a percent? So what we're looking at now is the price that she bought the book for. She bought the book for $3.20. $3.60. Bought the book for $3.60. The original price was $12. So $3.60 over $12 is going to lead us after we put that in our calculator. 3.6 divided by 12 will leave us with 0.3. So 3.6 divided by 12 will leave us with 0.3. And what we will do is we'll now subtract our 1 whole. So we subtract our 1 whole, and that leaves us with a 0.70. So Samantha was working hard, found that deal, made that hustle, and saved 70% off of the original price. So good job, Samantha. Good job, Samantha. I'm going to go ahead and write in this example 4 because I'm looking at my computer and I don't know if you guys will be able to see that. So I'm going to rewrite that in. I'm sorry. I thought that color would show up better than it did. So I'm just rewriting number 4 for you guys so that way you can see. So number 4, the answer for number 4 was 24%. It was 24%. Alright, that seems a little bit better. I'm sorry, I'll use darker colors from here on out. So, forest green. Alright, so this one, when I was working on this one actually tripped me up a little bit. So, the boiling point of water is lower at higher altitudes. So that means it boils faster at higher altitudes. Water boils at 212 degrees Fahrenheit at sea level, which is where we are. So it boils at 212 degrees sea level in Florida. If we were to increase to 10,000 feet, it would boil at 193.7 degrees Fahrenheit. What's the percentage of decrease of decrease in the temperature to the nearest 10%. So what percentage, or what is the percent of the decrease? So decrease, we're looking at the decrease, which is the 193.7 over the original, which is 212. So if we put this in the calculator, because look, I'm going to be honest with you, I cannot figure that out on my own. I could do long division, but since I'm allowed to use a calculator, I'm going to. 193.7 divided by 212 is going to give me this very elaborate and long number. It's going to be 0.913 ... a bunch of other numbers. I'm only concerned about this right here because it told me that it's looking for the 1/10 of a percent. So it told me it's looking for the 1/10 of a percent. So I know that if I'm looking at this in percent world, that this is going to be 91%. Right? 91%. So then I subtract my 1, as I normally would, and that's going to leave me with 91.91, right? So, what percentage of the decrease of temperature is the nearest 1/10 of a percent? So what would I need to do in order to get this all handled? Well, I know that the decrease is not going to be 91%, but I'm trying to figure out what I did wrong here. So let me look. 0.91 minus 1 whole. That is not 91%. Aha. Looking at numbers all day will do this to you. So take your breaks when you're doing your homework. So 0.91 minus 1.00 will leave us at a 0.9. So it's going to be a 0.9 or a 9% change. It's going to be a 9% change. Alright, tricked myself up. I hope you guys were able to get that. But I tripped myself up. I don't even know where I got... Oh, I got 91 from there. Okay, makes sense. Makes sense how I made my mistake. Alright, so 9% change is what we have here. Alright. Now, I will leave this up here. I will make it a little bit smaller so everybody could... so you could see the page. I will leave it there. So if the sub wants to pause here and let you guys take your notes, you are more than welcome to do so. So you can pause, take a look, see what you need to figure out, and then come back and we'll move on to the next part. If you guys are good to go, then we're going to go ahead and go to the last part, which is, why did the termite like expensive hotels? Why did the termite like the expensive hotels? Well, you are going to find out. What you're going to do is you're going to solve the problems below. You're going to find your answer in the answer column and notice the 2 letters next to it. Write these letters in the 2 boxes that contain the number of that exercise. So for example, number 3, if you were to solve number 3, whichever letters you would get for number 3, you would put right there and right there. So if you solve number 3, whatever you would get from here, this would go in your number 3 boxes. And then if you were to just start from the top and solve number 1, whatever you got over in the left hand column, you would put in the number 1 box. Whatever you got for number 2 would go in the number 2 boxes. So this is going to be your assignment for today. You are able to work in groups as long as you are on a level 2. Please don't get too crazy. Remember, there are 31 of you guys and 1 teacher. So when you guys talk, it gets very loud. So please make sure that you are keeping it on a normal level. Alright guys, thank you. I will see you tomorrow, or I'll see you Friday. Remember, you have your quiz. So your homework is to study your notes. Make sure you're ready, and I'll see you in the morning. Later.